Oh, it's that time of year where I need to edit the card from saying 2025 to 2026. This show is supported by you. This is Kapago for January 9th, 2026. Keep up to date with the important happenings in the Go community in about 15 minutes per week. Yeah, not this time. Not this time. I'm Shai Nechmad.
I'm Jonathan Hall.
Happy New Year, Jonathan.
Happy New Year, Merry Christmas, Happy Hanukkah, all those fun holiday things that we all did.
Yeah, now it's time for getting back to business.
Woohoo.
20 honey sticks, back in business. All right, we have one update about conferences.
Yeah.
And then we are going to have a sort of a different episode. If this is your first time joining us, this is not our normal pace. We're just going to go through everything that happened in Go 126 and try to summarize it so you know what's this new release about.
We should say what's about to happen because it's not released yet. It should come out next month. But we have a pretty good idea what it's going to contain. So, yes, as you mentioned, conferences. A couple episodes ago, which feels like sometime late last year, I don't know when that was, we had an interview with organizers from GopherCon.
I have a long history with Go, I guess. I worked at Disney, and we started playing with it early on, me and some coworkers in like 2009, 2010, late 2009, early 2010 when it was first released. Seemed interesting. Didn't really pick it up then.
Tickets are finally on sale, and they reached out to me directly and asked me to let listeners know if you're fast, you can get a $200 discount before the end of January.
Hot damn, $200 is nothing to sneeze
That's
at.
right. GopherCon.com, early Gopher tickets. There's a total of 100, and I bought one. So there's only 99 left. Actually, it says 76 as of this recording. So the first 76 listeners to head over to GopherCon.com and save $200 on their GopherCon ticket. GopherCon's coming up in August this year in Seattle. We'd love to see you there. We'll probably try to...
Oh, in Seattle?
Yeah.
I might fly over.
Well, you better go buy your ticket quick.
Honestly, I might. I might just.
But also, there may be some sort of collaboration between the show and the conference happening at the conference. Details to be determined. We're working on something.
TBD. Yeah.
But go buy your tickets now before the cheap ones are gone.
Yeah, so you can scalp them later. Oh, wait, no. Don't do that. So Go 126 is coming out in February. And I've waited for Anton to pull out the release notes. Luckily, he did it just in time. This is one of the most exciting releases I've seen, mostly because none of it is controversial. It's all good. There's nothing I look at here and I'm like, like generics or whatever. It was very, why are you doing these? This is just improvement-y release, which is, I think, a super strong benefit of Go. And we'll talk about all the features. But I just want to say I am 100% using Anton's release notes. We'll put a link in the show notes.
We'll also link to the official show notes, which are the boring, non-interactive version, but they're official. Yes. So you can look at both.
We had an interview with Anton. Of course, he was on the show.
Okay, my name is Anton. I do some open source stuff, and I write interactive, maybe I can call them guides or books, and interactive articles on my blog. That's mostly what I do in my free time.
Yes, I agree with you, Jonathan. The official release notes are pretty dry. So I am 100% using Anton's ones, which I highly recommend. It's a really good service for the Go community. And let's get it started. Who's kicking it off? Is it me or you?
I want to start with something new.
Nice.
The whole episode is new, right? There's a newness in Go 126.
New is always better.
Always. We've talked about this before, and I've ranted about this even on a video I did a couple years ago. 10 things I hate about Go. One of the first things in my list was that you can't make a pointer to a literal. So, like, this frequently comes up if you're building a struct and you need to set some default values, but one of the fields is a pointer. Like maybe it's a person struct and you have a name in there, but maybe you don't know the name all the time, so you want it to be, sometimes it's a pointer to string, right? and you want to say, now I know the person's name, it's Bob. You can't just create a pointer to the string Bob. Like you can't do ampersand.
Yeah, you have to put
Bob.
it in a variable and then use the ampersand. And it's like, wait, why am I writing C again?
And then virtually every single project out there has its own utility function to do this for you. Claude recreates it every time it needs it. Well, now that won't be necessary. The new keyword, which already existed, now accepts a value. Previously, it only took a type. So you could say like new int. Now you could say new 42. And it creates a pointer to that value for you.
Not just like normal values like a bool or an int, also composite values. So like a list of numbers or a full struct and even a function call. So I imagine the last one might be nice for people who are trying to do functional-ish things with Go. You know what I mean? So instead of defining a function, putting it in a variable and then putting an ampersand onto it, which makes the whole thing feel less functional because it's more readable. Now they could have more parentheses, just like they like from their Lispy languages.
Yay for Lisp.
What is not allowed to be new still?
Nil.
No new nils. No new nils in 2026.
What would that mean? Nil can't be a pointer to a, like, you can have a nil pointer, but you can't have a nil.
You can't point to nil.
Yeah. So
that makes sense.
Yeah.
I remember from my C++ days that pointing to 0000 was like a specific thing. I don't know if that's a thing in Go. Anyway, new things. Another improvement to the language of a thing that was before and now is slightly better, talking about generics, is improvement to generics. So generic, like function or a generic type, takes a type as a parameter, right? So let's say I have a function and it's called reverse, gets a list of whatevers, let's call them T, and reverses them.
Right.
A slice of T's, right? Sometimes you want to restrict these T's, right? The type parameters. So you don't want reverse to be able to accept anything. You want it to be able to accept generically something that is, for example, comparable. That's a super common use case. So even before 126, you could restrict type parameters and say T comparable. But you couldn't refer to type parameters within type parameters. So like recursively constrain types. This sounds confusing, more confusing than it is. But a good example is if you want to define the ordered type on like a generic ordered type, right? So you're saying, oh, it's ordered T, but the other thing also has to be ordered and also has to be T. So now you can say ordered that gets a T, ordered T interface.
So to clarify, like, I think you may have misspoken a little bit. I think you said you can't have type parameters in your type parameters. But you mean you can't have recursive type parameters? Like you could have a P that references a T, but it can't in turn reference a T.
It can't be recursive.
Yeah.
Yes. You could like have a map that has K and V is comparable.
Right.
K is comparable. But you can't have a map from K comparable to K in the K comparable. Like you can't have. Well, now you can. If you're using a lot of generics, I think it's useful for people who maybe write generators or trying to deal with complex data structures and algorithms. It's for you. Honestly, if not, just know that generics are slightly better and you can continue ignoring them.
This is one of those things that I feel like I wanted it once, but I can't remember why.
Yeah.
So anyway,
moving on.
Yeah, another generic improvement for error checking. You probably used errors.as before, I imagine.
All my errors are ass. Sorry. It was just too easy.
I'm not even sure what that means, but okay.
I don't like it because when I handle errors in other languages, it's exception catching. It's pretty easy to do like catch exceptions of this type, catch exceptions of that type. It makes the entire other parts of the language much worse. But that specific part of like narrowing the type of the exception I want to check is normally easier.
Yeah.
And in Go, I have to do like if errors as is something of a specific thing. And again, I have to use an ampersand.
Yeah.
Like with new.
You do, yeah. And I think the biggest problem with errors.as is the pointer semantics are confusing. And at two different levels, because you have to like pass a pointer to an error that the error can be cast into effectively. But sometimes it needs to be a pointer to an error, depending on whether that error itself is a pointer or not. Or like you have to really dig in, write a lot of tests to make sure you're doing it correctly. I don't have to write tests anymore probably after this. Thank goodness, because I hate tests. No, that's not true. But the change is now they have added errors.asType, which is a generic function which takes the error type as the type parameter.
Yeah, the generic type parameter. So the thing in the square brackets.
Exactly. So it's a little bit easier. It's maybe longer to type, but it's also on one line only instead of two. You don't have to do the little ampersand definition first thing. But I think it will help solve a lot of that. Like, is this a pointer or a pointer to a pointer? All that sort of confusion, I think, will go away. It moves
it from test to compile time.
Yeah.
Way better. And also, by the way, I think it's super readable. Like, if errors add as type, specific error type, and then the value. Yep. That makes a lot of sense.
It just returns that to you, which is more normal than the idea of like pass in the return value and let it be modified in, internally.
An output parameter. I hate that stuff.
Those are annoying.
And honestly, it's just a recommended drop-in improvement, right? Because it does everything that as does. Well, maybe we'll see it in Go Fix, which we'll talk about towards the end of this.
In about 3 hours when we get there.
No. Let's move fast.
Go.
Okay, next thing. Green tea garbage collector. So we talked a lot about the green tea garbage collector. I'm going to just not do it justice. It's a better garbage collector on average. Now, garbage collection is a super interesting problem. And Go obviously is a garbage collected, like memory managed language, right? It was introduced as an experimental in 125. So we talked about it like 9 months ago-ish at length. Should be more efficient on modern computers with many CPU cores. So it's not strictly better in every case. It's a trade-off. Normally, garbage collection that you learn in university, it's like mark and sweep. It's graph algorithms where you have the root of the program and then the root of the program allocates things and then these things allocate things and eventually you have a graph. The garbage collector scans the nodes in that graph, right? And like colors them. And then if it colors the same thing twice, now I can remove it from memory. These sorts of algorithms. Treating objects as nodes and pointers and edges and whatever doesn't really take into consideration like the physical structure of memory. With modern computers and modern whatever, this is sort of like random access memory. And if you learned like in university, about hard disks and whatever, when that was a constraint, when disks were still spinning and it wasn't all NVMe and SSDs, you wanted to do things that were closer together. I know, Jonathan, you like to hate on Windows, but the reason I understand this topic is because I used to really love clicking on the defrag your C drive button. Yeah. You remember that? Watching that little thing go by in color. Oh my God, so satisfying. Honestly, if someone implements a screensaver for that, I would totally install it. Anyway, the CPU just waits a ton of time because of this implementation in modern computers where you have bigger page sizes. So green tea, instead of being like nodes and objects, is like memory aware. It looks at, instead of individual objects, it's like I'll scan the entire memory in spans of 8 kilobytes and find small objects that I can like just yeet. And the algorithm is interesting. If you're interested in this stuff, I'd recommend you just look at it. But honestly, it's just should be 40% better in garbage collection overhead in real world programs that run on modern CPUs. And if you have like extra modern CPUs that support SIMD, which we'll talk about in a second, it's even 10% more. But there are no public benchmarks.
That's 40%. What did you say what the numbers were? 30% better and 10% more?
It's like 10 to 40%.
That's 40% more betterness.
Yeah.
That's how percentages work, right?
Yeah.
60% of the time, it works every time.
That doesn't make sense.
Anyway, this is enabled by default now. So if your programs suddenly get faster, or specifically, I think you should care about this if you're not running on modern hardware like backend services on Kubernetes, whatever, you can disable it and use the old garbage collector by doing no green tea GC. And if you do that, please open an issue for the Go team to let them know that what case was inefficient. Because what I imagine will happen, since this option is removed in 127, is that in 127, they'll find all the little trade-offs and somehow smooth them out in this implementation and end up with a hybrid. At least that's what I hope will happen, so everybody can enjoy it. Mm-hmm. Green tea, everybody. Not supported by Cup of Go, which is strictly a coffee-based program.
All right. Next up, more percentage of improvements, faster CGO and syscalls. I wasn't going to go to the details here, but I just can't resist the urge to mispronounce a few words. So,
Okay. Great program. Great idea for an audio-based show.
That's right. So, in Go, we have these things called processors, not to be confused with like a physical processor, but it like represents a programming unit that can process something. Represented as P. And previously, we had the idea of pruning, piddle, and pig stop. It's not quite right.
Okay.
P running, P idle, and P GC stop. And also P syscall. These are different states that a processor could be in. They have eliminated P syscall, which makes certain syscalls faster, especially in CGO, up to 30% performance improvement. So we add that to the 40 you just talked about. We're already 70% better.
Hot diggity damn.
Closely related to that, except not really, but it's performance.
But wait, it's only for CGO, right?
It's for
so who benefits from that and who doesn't benefit from that? What does CGO mean?
If you use CGO, then it benefits you. CGO is C code called from Go, basically.
Got it.
Probably not going to affect most of your programs most of the time. If it does, then why are you using Go?
Go and standard library and whatever, and it's not relevant. But honestly, a lot of programs do use CGO for library bindings, like if you use a graphic library or a database driver.
Sure, or FFmpeg, or maybe SQLite, or there's a whole bunch of things you might be using.
Yeah, and if there's a specific syscall you want to call that isn't exposed by the standard library syscall package. Cool.
Also, on performance-related issues, faster memory allocation for small objects. I'm not going to go into the details here, but if you're allocating memory for objects up to a half a kilobyte, up to 512 bytes, it's faster now, up to 30% faster. I think we're 100% better Go already if we add those percentages together.
Go runtime drops to 0 for every program. Apparently, solving computing, it was easy. You just had to use Go.
To be serious, though, the Go team estimates a 1% improvement overall from this 30% improvement to specific cases. So that's still pretty impressive.
Yeah, just shaving 1% off. I also love, I know you didn't want to go into the details, but I actually love how they got this improvement, which was take the general purpose implementation for memory allocation and just putting in a specific jump table for small objects. So like take this hot path and just implement it using jumps, to make it as best as possible, and then move on to the like general purpose implementations for bigger objects. Sometimes it's a simple things, not simple. And for our data science, math people in the audience, there are experimental support for vectorized operations, which immediately shakes me to my core because I don't know math, but I'll try to explain it. This is actually a hardware architecture specific thing and not a math thing that allows you to run SIMD, SIMD, single instruction, multiple data operations. So like a low-level package, it allows you to run a single instruction that does like calculation with a lot of data. If you're like me and you're coming from assembly, but you're also like me and you learned assembly, like a simple assembler language like Turbo Debugger or whatever, you're aware that you can like compare two registers or, multiply them or move them or whatever. But the SIMD operations allow you to do it with like large vectors of numbers and like add or compare or convert or mask or rearrange or divide or dot product, which I think is the highlight one, a bunch of vectors. And why would you want to do that? This is super relevant for recently relevant use cases. So, video and audio encoding, ML inference, scientific computing, and even things like crypto and compression could benefit from SIMD instructions. This is experimental still, so it only uses a specific set of instructions. So it's probably relevant for specific architectures. And honestly, it probably has a lot of bugs, but try to use it and give them feedback. And you can see that the benchmark is like so much faster, which is not surprising at all, right?
What percentage faster? Because that's what matters.
I can quickly try and compare, but it looks like at least an order of a magnitude better. So if you could do, add on two large vectors, it used to be 100 megabytes per second. And now it's not 100, 11,000 megabytes per second. And now it's...
So it's like 90% faster.
Now it's going to be 127,000 megabytes per second. I will say this is like a GPU-y thing that you can do on the CPU. So I think it's going to be really good for things like Olama. And, if you're trying to build all these things and not rely on people having GPUs, which I feel is a trend. I don't know about you, but I feel like a lot of people want to do like in-browser small language models or on-device, on your phone, audio to text, like running Hugging Face models and whatever. I don't want to get into the whole AI and where it runs debate, but I feel like people are trying to run AI in more places. This is like the sort of a backbone operation that eventually will lead to people easily writing these, like people like the Hugo people we had on the show. Like developing these libraries and tools for this stuff. Cool things.
So basically, we can say Go has MMX support now, right? Like it's 1993 again. All right,
everything old is new again.
Yes, that's right.
I've got a secret.
Uh-oh.
I've been hiding under my skin. Dun, 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 dun. All right, it's 2026.
Listen, do you want to know a secret?
Oh no, I'm referring to Mr. Roboto, right?
I was referring to a different song.
Yeah, but it's 2026, no?
Okay, very, very good.
Yeah, so Mr. Roboto has secrets, and Go now has a secret mode. We discussed this pretty recently.
Yeah.
So I'm going to go over it very briefly. But when you're using things like TLS, let's say you're setting up a web server and you want to protect it, right, Jonathan?
I always want to protect my web servers.
So you set up TLS. What properties would you like TLS to do for you? What does it do?
It makes things magically secure.
So more specifically,
it encrypts my data.
Yeah. So it encrypts your
prying
session.
eyes. Yeah, prying eyes can't see what I'm sending and receiving.
Using something called a private key, right?
Yes.
And what happens if you leave your private key out? You're going out to Starbucks, you're getting their 500,000 calorie milkshake for the season, and you're leaving your laptop open. Someone comes in, steals your private key.
Then they could read my secret messages.
So ideally not, because there's something called forward secrecy, which not a lot of people know about. But even if an attacker gains access to long-term secrets, like your private key that you left on your unlocked laptop in Starbucks, not secure.
I won't do that again.
They shouldn't be able to decrypt past communication sessions. So, while they have your private key, they can decrypt current ones, but past ones they shouldn't be able to. And then you rotate the key and everything's good. And to do that, you have like ephemeral keys. So like, a session key. So not only a private key, but also a session key. But if someone has access to your server, they might just write down these ephemeral keys as well. These session keys from memory. And in, like Rust or C, you could immediately delete these keys from memory immediately after using them. But in Go, you don't manage the memory. So you can't really do that. Well, now with secret mode, you can open like a closure in which everything gets immediately deleted, and not only deleted, zeroed out. So even if you have like a stack overflow, buffer overflow, some sort of memory leak between processes, you'll only see zeros there. As soon as the garbage collector decides they're no longer reachable. So even within the secret closure, it's super fast.
Oh, wow. Okay.
If you have sensitive information that doesn't need to stay in memory longer, do that. I will say, don't overuse this unless you know you need a secret mode, because this is clearly super inefficient.
Right.
And you don't want to do that if you don't need to. It's not meant for normal developers. It's basically for developers who implement cryptographic libraries and apps only. And if you're writing an app, you should just make sure that your library does use secret.do behind the scenes and not do it yourself. Probably. Basically only aimed at like Filippo, right? But Filippo, I hope you like your feature.
I have a crypto one I want to talk about too. It's called readerless cryptography. Here's the long and short of it. So when reading from this random input string, the APIs do not commit to a specific way of using the random bytes from the reader. If there's ever any change to the cryptographic algorithm that changes the way those bytes are used, It could, if a program is mistakenly tied to a specific implementation, it could start to fail in strange ways. To circumvent this, Go made an interesting decision a while back. I don't know how long ago, but they actually ignore the input from the reader without telling you.
What the hell?
To be safer.
Okay.
And the change here is to make that more explicit.
So that's about secret mode, but we have more crypto stuff to get into.
We sure do. I have a couple of different things here. The first one, readerless cryptography. I love that kind. That's where I write a secret and nobody ever reads it. It's kind of like writing to dev null. Wait a minute. That's not what this is. So readerless cryptography. There are a number of crypto functions that take an IO reader for random data. Hopefully you're always using crypto.rand for this, not math.rand, although math.rand might make sense for testing or whatever, but for real stuff, you always want to use crypto.rand. The problem is sometimes a crypto algorithm might change internally in a way that changes the way it uses those bytes. So if you have, this might mostly matter for tests, but I suppose it could matter in other cases too. If you have generated a key this way and codified it in a test, for example, and then you upgrade Go versions to a new version that uses a different algorithm, your tests might suddenly start failing in unexpected ways.
Not because of any hypotheses that the test is actually testing that's actually failing, just like the sequence or the amount of bytes read is different.
So to solve this problem in a roundabout way, the Go team has made the decision to just ignore those readers now.
So it doesn't matter what you pass, it's going to use the same random source.
It's going to use a correct, cryptographically secure random source regardless of what you pass in.
And here's a stupid question. Yeah. Why not remove the parameter from the function?
Yeah, because that would be breaking a breaking change, right? So I suppose they could do that in a future version. They could add two methods right now, right? Two functions. One that takes it, one that doesn't. But
this is like a total API breaking change. Yeah. You know, all your programs are going to fail on expected one parameter, but got two. So they don't want that. So they're just ignoring the second one.
Exactly. And this applies to a dozen or so different functions in various crypto algorithms. You don't need to change what you're doing.
Unless you're writing crypto.
Unless your tests are going to suddenly start breaking. If you have tests that depend on something like this, they will start being random when you were expecting them to be deterministic. So you'll have to write new tests.
Luckily, this change also includes the set global random function in the crypto test library. So you'll have to change your tests, but only once. Yep. Cool. Another crypto thing happening in the crypto sphere, which honestly sounds like that new structure in Las Vegas, which I'm planning to go to next week, is a package that implements hybrid public key encryption, HPKE, which has an RFC and whatever. You can go read it. It's a new standard for hybrid encryption. So
why don't they just jump straight to electric?
Nice. Honestly, I had a friend get stuck with an electric car with a Rivian on Tahoe and run out of battery because the only supercharger is in Jackson. No. And then he waited 12 hours for a charger spot. So I think there is still
okay, so that won't happen with this library.
Yeah, for sure. If you learned about cryptography and asymmetric cryptography, you're probably aware of the concept of a public key and a private key. And, I give the whole world my public key and people can encrypt with it, but I can only decrypt it with my private key, et cetera, to create like a shared secret without having to switch private keys between people. But that doesn't work for like really big pieces of data. It's mostly used today. RSA and the current algorithms are currently mostly used to handle, here's my key, here's your key. Let's do that with RSA. And then the rest of our communication is using symmetric encryption. This like HPKE implementation ostensibly should have all the benefits of public key systems, but be able to encrypt very large files or messages. There's a lot of implementation things going on, but this is the right way to do public key encryption right now. So if you've ever implemented like RSA or used one of these algorithms, you should switch. Also, as time goes on, people find more and more ways to defeat old algorithms. One example I like is that Shamir, the original researcher from the RSA, so he's the S in RSA, he put out a research from Ben Gurion University that if you put a phone, have you heard about this side channel thing?
I don't think so.
You put a phone next to a desktop computer on the same desk, that is encrypting like private keys in RSA, and using the phone's gyro, you can, if it uses the same key, which is very normal for a HTTPS server, they were able to figure out with a very high level of certainty the key after a few hours, just based on the desk's vibrations, which is crazy, right? I think it was a combination of vibrations and audio from the processor or whatever, but probably a newer algorithm if it doesn't have any glaring security vulnerabilities, which at this point, if it's in RFC and it is a standard, it passed the test, probably better than like, I don't know, RSA, which I think is 80s or 90s tech. So a very cool encryption, public key encryption way, and you should probably go do that. It's even faster, like it's also faster, so like why not, right?
Right. All right. Next up, enough with crypto stuff. Let's talk about Go-Routine leaks. The new version actually has two related features. One is Go-Routine leak profiling, which is currently experimental, but this relates to this is newly exposed through pprof, where you may already know how to do memory profiling, CPU profiling, and so on. This will help you profile for Go-Routine leaks.
What are Go-Routine leaks?
Yeah, that's when your Go-Routine drips all over your desk and lets the phone read your secret keys.
Yeah, so it's just like stuck in a sync operation, right?
Yeah. If you have a Go-Routine that probably isn't doing anything, or maybe it's stuck in an infinite loop, but it's not exiting.
So I can detect them today using Go 124 using sync test, right? Which we talked about on the show at length.
If you've written an appropriate test, that would help. But
this is in production.
Yeah.
Which is way better. These things usually happen in prod and not in tests anyway, right?
Yeah.
I just used PyLeak to do the same thing in Python, trying to migrate from like sync to async APIs in Python. And boy, it's crazy to see how much better this stuff is in Go. But just like I don't know what's the word I'm looking for? Maybe commiserating. All the listeners who listen to this show aspirationally, but get their paycheck from writing Python code. Here's us commiserating together that we have to use things like PyLeak and the event loop and whatever, instead of just using these very awesome tools. And there's another awesome tool in the metrics, right? Yeah.
So Runtime Metrics is a new package that gives, or I don't know if it's a completely new package, but it has new capabilities to give you Go-Routine metrics at runtime. So if you, which I'm sure is what the profiling is built on top of, but if you want to do some lower level stuff and do your own profiling or metrics gathering, you can do that too. With
if you metrics. Like, I imagine you put this in like your Grafana dashboard or whatever, and then if the numbers go up, that's bad, right? Because it means you have a lot of Go-Routines waiting, and maybe your CPU can handle the demand or whatever. You can count how many Go-Routines you have and also how many OS threads you have, which is also an interesting, like if you have a imbalance there, you have like a single thread running a lot of Go-Routines, maybe you want to re-architecture your like concurrency thing to have fewer, to like utilize cores more efficiently or whatever. More metrics. DevOps people are going to be happy, right? All right. Reflective iterators?
Yes, this is fun. So we have, you may recall the iterators were added, the ITER package.
Of course. You hated it with ITER 2, Zip2. I didn't
like the naming. I love the functionality. I don't like the naming. Anyway, they were adding that now, as we've started doing over the last few versions, to new libraries. Now the Reflect package gets some iterators to iterate over fields in a struct, things like that. So it's just a natural evolution of adding new capabilities to the Reflect package.
Yeah, I like it. The example, again, shouting out specifically Anton here, where you can reflect type 4 on filepath.walk func. So you can look at the ins and outs. Literally, that's the function name, which is very cool, of this type. So I don't know. I thought it was very cool. Values and methods. Like using the reflective iterators thing. I don't know where I'll use it. I've never had the need for it, but it's very.
I don't use reflection very much, but if I do in the future, I'll probably use it, but don't use it that much. Another one I won't use very much, but I'll be happy it's there when I do need it, is the ability to peek into a buffer. And we talked about this many episodes ago, I think when it was approved. So I think it's byte.buffer did not give you this ability before to let you peek into, I think you could do it on a file, but not on a byte.buffer, which is basically just read the next byte in the buffer without consuming it. That's been added. It makes certain operations a lot more efficient because
that
you can
care about
non-destructively
specifically, like JSON parsing.
JSON parsing,
whatever.
JSON parsing, yeah. Or any kind of parsing where you're like, I don't know if the next thing is a string or an array, using the JSON as an example. You can look at that and read the next byte. Oh, is it a curly brace? Is it a square bracket? What is it? And based on that, I can then branch to the next thing that consumes the byte. Prior to this, if you needed to do that, you'd have to like reconstruct your IO reader in a weird way to get the same functionality.
I will slightly correct you and say that you can peek into as many bytes as you want. It gets a parameter. But normally you would just look at the next character or a few bytes. This is also useful, let's say not just JSON unmarshalling. You're writing a file type thing and you want to read the first magic bytes, right? Or things like that. It is kind of weird, in my opinion, that it doesn't give you a copy of the data. It gives you a pointer to the real data in the buffer. It makes a lot of sense that's the default behavior because you can always clone, but it is risky because you can peek into a thing. And to me, peeking sounds like a read-only slice of data that I'm getting, but then I can edit it because there's no such thing as immutability. And I'm actually editing the underlying buffer. So use with caution. What's the thing, the American thing? Buyer beware, right? A smaller one, process handle. So if you're using Go on Linux and Windows, instead of doing stuff with processes using the process ID, which might change and isn't the best, especially, you're running in a container, not in a container, but it can get confusing. You can get the file handle, which is like this is not file, sorry, process handle, I meant to say. So you can get the handle to the process, which is guaranteed to refer to the process, even if it died, right? Because what can happen is you get a process ID. By the time you want to do something with that process ID, another process took that PID, took that number. But if you have a handle, it's guaranteed to refer to the process, even if it's already terminated. Like it crashed, but you're still looking at the same thing. And that way you don't get mixed up with logs and whatever. A great suggestion and improvement from Keir Kolishin. And, it makes sense when you see who are the people behind these. We mentioned the crypto stuff is obviously Filippo is the person who suggested those. This one is from Keir Kolishin, who is the Run C open containers contributor. And he writes, Podman and all these things where missing a process and, grabbing the wrong container is probably a thing he deals with a lot.
Cool. Next up, signal as cause. Have you ever used the signal.notify context function before?
Yeah, to grab a signal when someone kills the server. These sorts of things, right?
Yeah, typical thing is maybe that's one of the very first things you do when you're starting up a server process. You signal notify context to create sort of a global context that is canceled when someone terminates the program.
So you control C. Someone control C. You want to try and close all the connections nicely, and then if they control C again, they're like, yeah, whatever. I'm all right. Got it.
Right. So up till now, when that happens, you just get a context canceled error. So your database operation that was in the middle of happening when you hit Control C, it just gets context canceled. You don't know if it was canceled because of that or because of some other reason. Well, now signal notify context will still return the context canceled, but it decorates that context with a cause, which will tell you which signal caused the cancellation. So if you care in your program, you can examine that context after it's been canceled to see, was this canceled due to user interaction or due to a signal, and then do what you want with it. So that's cool.
It is the string of the signal.
Yeah, so it just returns an error string. It doesn't give you any clean way to map that back to the signal itself. Although there has been some comments on the issue tracker to hopefully add that in a backward compatible way. We'll see if that gets any traction.
It does have uses, that I probably don't think about, but the original thing was, using cancel, cause, func, whatever. It has uses that I don't understand, but it would be nice to just print out the signal you got, I guess. Yep. A simple one that if you implemented yourself, you're probably, why did they add it after I implemented it myself? comparing IP subnets. So why would you want to compare an IP subnet to begin with? What is even an IP subnet? I don't know how far to get in this rabbit hole. An IP subnet is the thing where you have 10.0.0/16.
Yeah.
So it's pointing at a bunch of addresses. Why would you like sort or need to compare subnets in general? It's when subnet relationships matter. So if you're writing a routing table, or if you want to know if one IP address contains another. So if someone configures like, oh, these are my IP subnets that I want to support, you can tell them, oh, you can merge these two items into one because they're containing. Or if you want to check firewall correctness, if you want to allow all addresses but deny some of them, and then the deny is bigger than the allow, it contains more addresses, then that's just wrong. Right? And you want to highlight in whatever firewall you're implementing right now that this is wrong for many other reasons. I also think one reason is for people who are writing SIM systems, like for security, to make lookups faster and whatever, if you need to compare them, basically. So now you have parse prefix, and you can easily sort by the netip.prefix.compare function. The sorting is not obvious, because what if you pass a invalid IP? Or what happens if you compare IPv4 and IPv6?
I would expect IPv4 to sort within the IPv6 space that it contains it.
Nope.
No. Okay.
It's always hard. It's always hard because this is not a natural thing, but the order is validity. So invalid addresses go to the top, then address family. So it's first IPv4 and then IPv6, and then by masked addresses, and then by the prefix length, and then by the IP itself, like unmasked addresses.
So if I have an IPv4 address and its IPv6 representation, they are neither equal nor sort next to each other.
IPv4 is going to be first.
That's weird, though, that like they aren't considered equal. I mean, and I suppose it depends on your application whether you want them to be equal or not, right?
So it's just that's the standard. There is no natural order to these things because you can't really compare IPv4 and IPv6.
For camels or pigs first?
There are more addresses. The address space is bigger. Yeah. So there is no like natural solution to this. So the way they solved it is, I'll just go with the standard. Right. Next up, context-aware dialing.
Yeah, another network one. So this is an interesting one because it's a problem that's been solved, but it's solved in a new way now. You can already dial. So first off, what is dialing? Dialing in the net package is when you create a new connection to a network service, right? And so long ago, back in the early days of Go, you had the net.dial function. You could pass it, say TCP, and then an IP address :80 to make an HTTP connection, for example. Then in Go 1.7 or whatever, they added context. So they needed the new dial context version, which takes a context as the first argument. So if it takes too long to connect, you can cancel it. What they've added now is a new dialer, a context-aware dialer that gives you a third way to dial now using context, but it's more efficient.
Mm-hmm.
I think that's it. I don't think we need to say more about it.
That's fair. Another very simple one, example.com. So you have an HTTP test server that you can use for doing HTTP tests. And the certificate already has example.com as like a thing you could use. And because of this, the client doesn't trust responses from the real example.com. So if you're actually trying to use example.com, it doesn't work. So, and obviously you don't want to go to the real example.com in your test, right? You're trying to use the HTTP test.
Unless you work at example.com, right?
No, I mean, yeah, but you wouldn't create your server with HTTP test.new server. You could just use HTTP.server. So now the client redirects to the test server instead of the real example.com.
Right.
This is, funnily enough, I don't understand how this came up or why did someone fix it, but it was like from an issue from 2019 and someone just got to it. I'm trying to
COVID area boredom.
Yeah, I don't know, but it's a fix. It's sure. Just strictly better. And I don't know who owns what even is an example.
Ayana owns example.com.
This domain is for use in documentation examples without needing permission. Avoid use in operations. Okay, so now we're avoiding use in operations.
There it is.
All right, home stretch.
All right, next up, optimize fumpt.rf. You ever get confused, should you use fumps.rf or errors.new when you don't have?
I got CR comments on it in the past. Like one of them is better from the other. This is not a bike shit to bike shit on anymore, basically.
Yeah. So, but yeah. So basically, errors.new was more efficient because it didn't do all this internal parsing of things that didn't need to be needed. You can stop worrying about that now. Disable the linter. Fumps.rf is just as efficient or very nearly so after this. So that's it.
And another one that's super easy is optimized IO read all, right?
Yeah. This one's another 50% better. So Go is now 240% better overall, I think.
Yeah.
Basically, more efficient internal allocation for buffers when doing IO.read all. That's it.
I don't really understand how this wasn't very, how did we only find this now? You know what I mean?
Good question.
It's very, I would expect these things to come up just because people use IO read all the time. But also, I guess it's never in the hot path of anybody.
Like I mostly use it in tests. I mean, I use it occasionally in production code, but like if it's something big, I try to use streaming.
Yes.
So yeah.
I guess that makes sense. One thing that's important for this one is go read the commit message. It's just the best commit message I've ever seen, basically, for the IO read all. If you're getting anything out of it, is that, which I know is a weird recommendation. Go read the commit message, but it's just very, very good. Multiple log handlers in log slog.
I love this one. It's going to let me stop using some third-party libraries that make me nervous sometimes. So yeah, now you can basically chain multiple slog handlers together, and it will iterate through them and write to all of them. So if you need to send to standard output and to a file and to your network, cloud provider or whatever, you can do them all with the same handler without using a third-party library.
What was the log product thing? We had someone on the show.
Spark logs.
Yeah, Spark logs. Yep. So you can have all of them. This is very useful. Can I tell you what's my use case for this one? So locally, I want my logs to be like console logs and very pretty and you know what I mean? Like colored, but always in production, I want single line JSON logging. And the reason I want single line JSON logging is I can use whatever cloud provider I'm using to read my logs at the moment to do where message equals a thing and then the other field, like structured logging. I don't need to explain the benefit. But sometimes I want to run these queries locally as well. You mentioned the GoRoutine leak profiling before. I did that with async IO runtime in Python, and I really wanted to use agrind to locally, do some statistics on my how many Python threads, it's not threads, but whatever. How many Python things I've running at the time. So putting the normal log, standard error, the pretty, colored, whatever log, and then putting a debug log into a rotating 50 megabyte JSON file on my hard disk that I can then query using JQ or agrind is such a useful use case that I've done it to every single server that I'm seriously working on, where I'm actually using these logs. And this makes it so much easier.
Awesome.
Very cool.
I think we're at the homeward stretch here. Just a couple more to go, right?
Yeah, very, very simple things. Talking about writing stuff to disk to, using them as a developer. Test artifacts, something we talked about in the past. This is not something you couldn't do yourself. What you would normally do is, let's say you are running a test and you want to write the result to the side, right? To view it. I've written a lot of AI-based, LLM-based tests recently. Not meaning the LLM is writing the test, although that is also coincidentally true. Meaning inside the test, I'm calling an LLM, which is inherently sort of unstable sometimes, especially if the test is doing something that is, generative in nature. So I want to make sure that something gets generated, and maybe I can hypothesize it has to contain the word, Jonathan. I can't promise the exact format, but sometimes I want to save it to the side to just look at it, right? What I would do is for every test, I would put a /tmp/ something, every time I would jig up something different. Normally I would just use the local repo directory, and then sometimes forget to not commit it, and then I would commit test artifacts and I have to rebase blah. Now you have t.artifact directory, T or B or F, whatever test you're using right now, just has an artifact directory and you can dump things there, like your log file, which we just talked about a second ago, or, various artifacts. And if you use minus artifacts, it's going to just be there. And if you don't use artifacts, they are stored anyway, but they're deleted after the test completes, which I don't understand fully. Why would you ever do that?
I suppose that way you can use it as a temp directory during tests, maybe? Or maybe it just exercises that code, make sure that you don't have permissions issues or something that you don't detect until you need them. Or I don't know.
The only thing I could see it useful for is if you're like putting a debugger in the, like before the test ends, you know what I mean? And you're running the tests with a debugger and then you're stopping and then you're looking at the artifacts.
It can also be helpful if your test crashes mid-run that you have the artifacts, I suppose. I don't know.
Oh, true. So anyway, test artifacts, a nicety that is very, very, very nice for sure. And last one, all these awesome features that we've talked about. How will I remember to change all my code to include all of them? And this is 126. So ostensibly, there are 25 other versions that now I need to go and read to understand what's going on.
It's hopeless. There's nothing you could possibly do. Wait a minute. What's this one?
Don't call it a comeback. It's Go Fix. So you have Go Vet that will report problems, and Go Fix will modernize to use them in a safe way. So you can just run Go Fix and it'll fix all the things. Do you remember the 4var thing? I think it was one of the first things we talked about on our show like a few years ago. You can do Go Fix minus Go var and it'll just fix all the things. But honestly, just run it in a pre-commit on all the things and it'll just modernize your code because these are safe changes you can do. So, instead of for in a slice, it'll use slice contains, for example. Right. And you don't have to remember that, which is an important thing because I feel like a lot of code is getting generated right now. No. And the code that is generated is trained on old versions. But you want to use these new, better functions. And you can find a full list of analyzers if you're interested in that sort of thing. Like, it's sort of like reading through the entire linter list of Golang CI lint. And there are some obvious things here, host and port and inlining things and min and max, like using the min and max functions, which I don't always remember because they came out after I started using, or omit zero, which we talked about on the show. You don't have to remember them. GoFix will just do it for you.
Awesome.
Whew. I can't believe we made it.
This is a big release. It feels different to me than some of the other big releases because it's a bunch of small changes. Like none of these changes individually feel game changing, except maybe the very first one, the new. That one I've been waiting for a long time. But in aggregate, this feels like a big change.
I think for specific people, finally I have secret mode. Finally I have vectorized operations I can start playing with. I've been working around it with C. Yeah. Finally implemented hybrid public key encryption, which I need. I also think, by the way, Go routine leak profiling is pretty big. That's because pretty cool. If you've used sync tests, but you're still having Go routine leaks in production, this basically solves it for you, right?
Well, it helps you find it, yeah.
But like I said at the top, it's a big, big, big release that's made up of a lot of small, very good improvements. Useful updates and a lot of performance upgrades. If you just upgrade to Go 126 and you don't read anything, you just do it automatically, your program might get 60% faster just for no reason.
Absolutely.
If you're using a lot of like small objects and you're allocate heavy and you have a lot of CPU cores on your thing and you just upgrade to 126, you might cut 50% of your program's overhead just by upgrading, which is crazy good. I might be overstating it with the 60% because I think it's 30% on the garbage collection time. And I hope your program isn't spending 100% of the time on garbage collection now that I'm saying it out loud. But you know what? Even a free 3%. Who doesn't want a free 3% cash back on their cloud costs? You know what I mean? Whew.
I think we did it. We made it through in just an hour.
Just one final question. When is it released?
February. That's all we know right now.
What's your bet?
February. I'm always going for Valentine's Day, but I'll bet it won't be then. That's when I want it to come out.
Yeah, for sure. Well, we'll see. We'll see when it comes out. I hope it's like February 1st because I can't wait for this release to come out already and start playing around with all these features.
Looking forward to it.
That does it for 126.
126, woohoo!
Stick around after the ad break where we have an interesting interview with Arthur about their transformation to Go in their pretty interesting and unique company.
Sean, I had to run, so I'm doing the intermission by myself. Sorry for the extra long episode. Hope you thought it was interesting. A quick reminder to check us out online, cupico.dev, where you can find links to all past episodes, links, show notes for this episode and all past episodes, transcripts, swag, all sorts of fun stuff. I'm not going to ramble for too long, partly because I don't remember what I'm supposed to be saying. And also we have another interview coming up that I just talked about. So this is an extra double long episode, triple long episode, something like that. It's like 400% better than usual. Hope you enjoyed the show and hope you enjoy the interview.
Jonathan, what's your favorite diagram?
A burn down chart? I don't know. If I took my favorite diagrams and like plotted them out, like and your favorite diagrams and plotted them out, I don't know how much overlap would there be.
Yeah, maybe we need to like find the characteristics we love and put like two circles, one here, and then see the intersection, and there all the good diagrams would be. Yeah. Man, I wish there was someone who knew a lot about Venn that could help us on this call. Oh, hi, Arthur.
That's a great intro. Hi everyone. Thanks.
If you were to plot out good intros and bad intros, would there be any overlap?
I'm here, the chief software architect at Venn. So just fire away any questions that you have. I'll be happy to.
Awesome. I love that. Just straight to the point. My first question. Boom, boom, boom. What's Venn?
So, right. Venn, basically our mission is to, like a Venn diagram, connect the community within the multifamily real estate business. So we provide an operating system for the multifamily real estate industry, right from the first time when you book a visit, a tour to a leasing apartment that you want, and up for your 3rd, 4th, or 10th renewal of your lease. So everything in one system. That's what we do.
So multifamily real estate means like apartment complexes, I guess?
Exactly. Yeah.
Okay. Does it go smaller than that, or like duplexes, or if I own 6 individual homes, does that count? Or
so not yet.
Okay.
But we are planning, and we have a lot of dreams. We are very focused on multifamily right now, and tackling those issues first. And I hope we quickly beat other businesses.
And you sell a SaaS?
It is. Yes.
Okay. So now here's a confusing question. When you talk about your software, what does multi-tenancy mean in your local vocabulary?
Yeah, so the word tenant gets a lot of meanings, and it's very confusing. And I'm all about clarity with terminology. I'm a freak about that in the company. So words do matter, and we call them residents on our part.
There you go.
So we have the tenants, organizations, and residents on our business models.
Very good.
Wait, so tenants, residents are like people.
Yeah.
And tenants is like the multi-tenant database.
Exactly.
Tenant. Yeah, got it.
It gets confusing when you talk to customers, but down with the technical team, we do understand what tenancy means. We have, and we try to avoid that word altogether. So we have the hierarchies: organizations, properties, units, residents, lease contracts, no tenants.
Right.
Cool. And this is only in the US, or is it like a global thing?
It's in the US. We do have some business in Israel, actually. But most of it is in the US, across the entire country, I guess. It's we have customers in Texas. We have property managers, owners, New York.
Yeah, I do want to, as someone who lived, so I own a place in Israel, but most of my life I lived in rental properties. And now I live in a apartment complex that's like managed by like a company, which is a first for me. And I think maybe, Jonathan, since you were also on both sides of the pond, like European listeners who are listening to this right now and never like rented from in America, this is a very different experience. So you're like dealing with a corporation. It feels more like renting out like ski equipment than it is how it felt, at least for me in Israel, like talking to some old lady who has an apartment and is willing to let me, like, you know, and you go up to her and her son helps you sign the contract and whatever. Yeah. This is like a very businessy thing that big companies buy a lot of homes. You know, it's even somewhat a political issue, but let's sidestep that because that's not the type of podcast we are. So you sell Venn to these companies, right? That own these apartment complexes, so they could manage like all the tenants, all the payments, all the whatever.
Owners and operators.
Yeah, you have like one thing you have in these complexes that was crazy to me. You have a guy that's in charge of maintenance,
and you have a concierge in some buildings on the front desk. It's like a hotel where you have like not a 5-day stay, but a few years.
Yeah.
And so it's an operation. It's not just like a guy renting out the place. So it makes sense that you'll need software to run this operation. It's like payments and setting up like tours. People want to come and see the apartment before they rent it out. What sort of things does Venn solve for these people? So I assume, I don't know, scheduling maintenance calls is one and payments is another.
Yes. So when you look at this, you got to look at the resident's journey across the entire industry. So you said it first, you need to book a tour. It's very businessy and we try to make it personal. Today with AI and LLMs, it makes it much more easier to give you a personalized experience when we have the data and we can feed it to an LLM, and an LLM can send you out a personalized invite for booking a tour or something like that. So you do have the agents that can manage those different workflows for scheduling a tour. That's the first thing that you do in the journey. You're a prospect, you want to schedule a tour, you're looking for an apartment. And then after that, you need to apply for a unit. You need to fill out an application form. And the application form has a lot of data to fill in. And we try to make it as easy as possible. So we do have an app for that person, for the applicant that wants to apply and invite co-applicants. And then it gets to all those legacy stuff systems, the PMS systems that all those property management company uses, where somewhere in their backend have like different, I don't want to do some name dropping, but there are a lot of accounting systems that we integrate with and need to sync the data into, so all the bookkeeping will be in sync.
And I will say, compared to various SaaS software you can develop, like messing up, this is like a B2B SaaS software play, but messing up a little bit of data here or there, or dropping a thing, is super detrimental to someone. I can just imagine like, oh, we built a data pipeline, we built it using the Node.js. Oh, we had the event loop was blocked, so we missed 50 payments out of 10,000. Not too bad. On the other side, it's like 50 people who didn't pay their rent this month and are like super nervous because what's going on with them. This is actually like it's housing. It's like super important.
So from the technical perspective, durability is critical on that point.
Yeah,
have to be successful eventually in sync. So they eventually
of the building or of the software.
The durability of the building is critical as well, but it's not on our end. But yeah, so you're looking at the journey. So you're a prospect, then you're an applicant, and then if you decide to move in and you're an approved and you pass the screening, there are a lot of screening tests to do with different third parties that you integrate with and send like KYC documents and income verification and so on. And then you become a resident. And this main section, where you're a resident, the living part of your journey, is something where we want to bring the extra mile. We have social modules that will allow you to interact with the neighbors, interest groups, events. We have amenities module where, I don't know if you know, but in some of the multifamily apartment buildings, the AAA buildings, they have amenities like the rooftop pool and barbecue grills, and some might have like a hydroponic garden, and you can actually book them for your purposes, like to do a birthday or just to go to the pool with your friends. And managing those bookings, schedule them. Some actually have golf simulator. So when you schedule the golf simulator, for instance, some are paid, some are complimentary, but you do need to manage the scheduling as well. So this is, again, another sub business that we're solving as part of our software. So there's a lot to do on our end. And then there's the renewal part where you want to renew your lease for another year or to move out, and there's a move out checklist that you need to fill in, an inspection checklist and so on. So a lot to cover the entire journey. And we provide all of the features during that time, as well as smart access integration, a lot of integration. And we try to make a very simple interface for the resident and for the property management team, for the on-site team, to see everything in one place, like a resident management system. So that's cool. A lot to do.
Yeah.
It's a lot of operation to operate.
I'm curious. I expect this is an industry that most people never think about. People who live in apartment complexes are going to probably download an app and they'll see some of this, but it's not something that's like forefront of people's minds, like, car brands and stuff. What kind of competition exists? Is this a wide open field? Are you the only player, or are there like thousands of players out there you're all competing?
There are not thousands of players. There is some competition. Of course, the PMS companies, the property management companies that became the backbone of the industry, where you manage all your billing and accounting, are trying to meet us from that side, meaning they're trying to create additional applications for handling lease applicants, and handling amenities for the concierge and so on. There are new companies, like there's a company called Elise that's started with prospect leasing and trying as well to meet from that forefront to meet the entire journey. So there are not thousands of competitors. I would say they're like less than 100, I think. But the main pain point today, I think, is what we call app fatigue. A common resident in a multifamily apartment like have 7 or 8 different applications. One for opening the lock, one for the intercom, one for the packages, one for paying the rent, another one for whatever. And this is something that we strive to eliminate. We want the resident to have a single application, and we want the on-site team to have a single back office system where he or she will be able to see everything about the resident and communicate with them safely and get the insights from there.
Awesome. So let's get to the point. The reason you're here.
Oh, yeah.
We're not here to talk about apartments, although that's interesting. We're here to talk about Go.
Mm-hmm.
How does Go fit into this whole picture?
Right. So when I started at Venn around almost 3.5 years ago, I met a company with a very, very small startup, like 8 developers, and they've been working over very trendy technology, I might say. It was like a 24 to 30 microservices written in Node.js, 600 or so Lambda functions on AWS, an SNS topic that streams events and choreography between those Lambda functions where one invoked the other and so on. And then you get an email about a recursive function invocation. So there was a lot of overhead with managing the infrastructure, and we were fighting against the infrastructure and against the velocity of creating features, creating value. Because with the existing, with node technology and microservices, we have the technical debt tax, where in Node every version is a breaking change. I guess you know that. And every library version that you update is a breaking change as well. Nevertheless, it might be a minor, it might be a patch, but it will still break the code. So a lot of this, and we were struggling with creating actual value, actual features, and the velocity was very, very low for development. So the first thing that I understood is it clicked with me with Melvin Conway, the Conway's Law, law that says that an organization, broadly speaking, will eventually create a system that reflects the communication structure of that organization. And at Venn, we were actually fighting that law because the communication structure was, like a hallway talk, informal. We were closing stuff during coffee meetings at the kitchen, while the actual technical deployment pipeline was very formal, like 24 CI pipelines and strict contracts between microservices and control drift and everything. So it became very, very hard to maintain. One thing that we tried to do first is to try and actually converge all those microservices into a single monolith. But I didn't want to create what we call in the industry a big ball of mud.
Right.
So another great architect, Simon Brown, had a very good talk about something he calls the modular monolith. This is what we actually started to build. We took all those microservices and we merged them into a single monolith where it is split into different modules. So the modules are not technical. It's not like you have the API layer, the data access layer, the business objects layer. You have different modules where you have business vertical for each. So we have a social module, we have a resident module, and each module is very independent. Each module will have its own data access layer, which should be internal only for that module. So it's like having microservices, but within and from that monolith, we intended to create multiple containers for different workloads. So the API would be built from this code and shipped to like whatever service. It could be ACS, Kubernetes. We use Kubernetes here. And this was the plan. And we actually started it. I wanted to start as frictionless as possible. And because the team was really professional with Node.js and JavaScript, we were using that to create the modular monolith. And very, very quickly, I mean, around a month or so into the project, I got a pull request. And that pull request changed the my entire perception. I got the pull request where, I mean, it was something, it's not intentional. A developer just used an internal package from a different module, like from the resident. It used some helper function from the data access layer of the resident module in the social module because it needed to map something about the resident. And it just clicked with me that there are no tools in Node.js to be able to encapsulate internal implementation logic. And it might work for microservices where you have no ability to import it because it's a whole different repository or package. Well, I might argue that if you really want to, you're still able to do that. But in other languages, not specifically Go, but we'll get to it, you have the concept of an internal package where you can create a module and say in that module, I want to encapsulate part of the logic so that other modules will not be able to use it, other packages.
So I'm not a JavaScript nerd by any chance, by any means. But can't you like either export or not export symbols in JavaScript and use closures and stuff like that to give you at least some of what you're talking about?
So you will export it, but as soon as you export it, it's available to any level of the hierarchy.
Oh, sure, yeah.
You need to export it to your parent module because it needs to be the access layer. But then if it's exported, it doesn't care.
Anything can import it, yeah, right.
Everybody can use it. In C#, you have an internal namespace, for instance. In Java, I think there is something similar.
Yeah, like protected or something.
Yeah, something like that, restricted. I don't really remember the name of Java.
It's interesting because you mentioned you're the chief architect at Venn. So like these access level things are a tool that's useful for you to make sure that developers are not it's sort of creating guardrails around, okay, this is what I want to be internal, this is what I want to be exposed when you're developing, because you can't review every single pull request. So these are like the sort of tools or guardrails or permissions, I guess, that allow you to shape the architecture more strongly. Or I guess the thing that was missing more correctly from JavaScript.
Exactly. You can put as many linters as you want. An ESLint rule will eventually be disabled if the patch is urgent enough.
Or if Cloud Code is lazy enough. Like, I solved it. TS ignore it.
Yeah. But it takes a comment to ignore a rule. That's it. And what I was looking for is something that will enforce architectural constraints to the point where a developer will not be able to override them. So this ability is priceless for me as an architect, but I think it is priceless for any team of developers that are trying to build good software and maintainable software. And I think that Go really, really shines in that prospect because First of all, you have the ability to internalize and encapsulate logic so easily and so simply just by naming a package internal. And that's it. Everything inside is not visible to anyone besides that parent module that holds the internal package. So easy. If you try to do, this is what in the industry we call the pit of success. You're throwing the developer to the pit of success, making the good things easy and the bad things hard. This is what I'm there for. And trying to figure out what would be the best approach for that. So that what breaks the camel back. Sorry. This is the PR that broke the camel's back. And I took it upon myself to take what we wrote in a month and rewrite it to Go. And I chose Go just because I was really familiarizing myself with Go at that point. I was moving from C# to Go. And I just really fell in love with the simplicity of the language and the talk of Rob Pike, how simplicity is really complicated. And that got me hooked with Go. So the magic where you can just onboard yourself into a language in 2 weeks, and I will talk about it and how the metrics change in our company as well with new devs onboarding so quickly to Go. The simplicity of the language is amazing. And there are 3 main points that I think got us as a team to choose Go, because it was not only my decision. What we actually did is we took a developer to use and write a new feature using Go instead of using Node.js. And we gave the developer like 2 weeks of onboarding and training sessions and so on. After 2 weeks, the experience of the developer and the code that we got was that it's just a joyful experience to code and work with that language. So this is what made the entire team agree that we will switch tech stack from Node.js to Go on our backend. I really, really pray for the time where you can use Go on the front end as well for web development, but I don't think it will ever happen.
I mean, I use Go for web development, but it's not very easy.
Yeah.
It can be done.
It's not a joyful experience as it is like writing backend services for sure. When you're switching tech stacks like that, other than the joy of developing, sometimes there are other, reasons like, we're using one of them, of course, being, the front end is in JavaScript. So if the backend is JavaScript, they can easily share types. So, the API like management thing is easier because it's the same struct in front of and in the back of any API request. Like it's going to be the same JSON if you're using normal REST or whatever. Maybe there's a specific library that's very easy to use. And clearly all the engineers already know JavaScript as well. So I want to play devil's advocate here a little bit and try to because this is a big, y'all are a business and switching tech stacks is a big cost. Now, I obviously here on the call, we're all biased and we're all going to say developing in Go is probably, I don't know, maybe Jonathan doesn't find any joy in anything anymore, but I think he likes programming I think he likes programming in Go compared to other languages generally. Like if I gave you 2 consulting contracts and I have you pick, Jonathan, same sort of domain, same payment, one in Go, one in, I don't know, some random high level language.
I wouldn't even consider the other one.
Yeah. You know what I mean? So I don't think we're trying to dismantle the core of your argument that it's more joyful or that it's more productive, but there are like other costs to switching a company's tech stack, right? Yes. How did you handle those objections?
Oh yeah, that was a very quick meeting with numbers. I mean, it was very easy with Node.js because the maintenance tax was really huge. We paid maintenance tax over and over again when we needed to, you have a microservice that you wrote in Go and you upload it. You wrote in Node.js, and you upload it to AWS. So there's a Lambda there. And you wrote it at Node 16 or so. And I mean, a year after you get a note from AWS, and listen, we're deprecating Node 16. You need to upgrade. And the upgrade process is something that takes time. not only upgrading the tech stack, but upgrading libraries that we used in Node.js broke the code as well. And this is something that I think very, very familiar to any JavaScript programmer, where you import a single library, the node module black hole and everything. So that maintenance tax was the golden ticket to get the switch, because a lot of the developers were heavily invested in maintaining services and maintaining the technical debt that was created. Go, with the Go 1 promise, eliminated that need. I mean, we started from Go 119. We're at 125. I just upgraded to 125. It was released and it was just easy. I mean, you just switch and that's it. You don't need to do anything. And I think that this mindset also drills down to the minds of all of the community developers, because all of the libraries adhere to the same principle as well. Most libraries written in Go are very, very strict with versioning and very, very strict with changing and breaking changes, doing breaking changes on their major version. So when your standard library and when the ecosystem behaves that way, you just get a maintainable software where you can just develop new features and you don't need to go back and do technical debt maintenance all over again.
So your like case was, okay, we're going to put down, like, you're talking like real estate, right? We're going to put a down payment on this migration. It's going to cost us, obviously, it's not going to be easy to change languages. Mm-hmm. But after a while, the look at all these like tech debt management things we're going to have to do if we stay on Node.js, just like integrate the number, integrate this to see how much effort we'll have beneath that graph versus how little we'll have beneath the Go graph, and just wait a little while and it's going to be worth it. How long was that cutoff point? Was it like, oh, in a year we're going to recoup our costs? Or was it like, listen, it's a no-brainer. In 2 weeks we're going to get all the costs back because of the Node 16, deprecation thing?
So I was really shaking at that meeting, trying to convince my boss to give the time for that project, because I know from experience, when you start such a migration project of technical stack, it never ends. I mean, you start it and at the end, you look back after 2 years, 3 years, and you see this legacy code behind. Nobody wants to touch it, but you still have to maintain it. And now you have the new thing that everybody wants to use. So you're going to end up with both. Mm-hmm. But I think that, I don't know really if Go was the reason, but it really made it easy. We managed in half a year to transfer like the Pareto, the 80% of our workloads to the new infrastructure using Go. And the 20% that's left require 80% of the work. But I think that after a year or so, or a year and a half, we've managed to transfer almost everything. We do have some still running Lambda legacy services, but they're really, really negligible, and we don't really maintain them. If something went wrong, we will just convert them to our infrastructure. So yeah, it proved as a success story, the migration to the tech stack. And I was surprised because I never saw an actual migration project like that ends up in this with those results. It was really amazing to see. And what was most amazing to me is how quickly we got all of the development team. Now we're around 33 developers and counting. How easy it is for a new developer to onboard to the project, both because Go is so simple to learn and because the architecture that Go really in some way forces you to simplify makes the code base very, very simple to learn. Yeah, it was an easy sell.
Cool. And any regrets? Anything? Maybe regrets is too strong, but like, were there any surprises, any negative aspects to this switch to Go?
Let me think about that. I never thought about that,
It's just all rainbows and unicorns.
Yeah, it's not. What's harder?
They had to evict all front-end developers from the properties themselves. They're like, you have to write in Go to live in one of the properties. No, I'm just kidding.
I can't find anything that made it harder. I mean, I guess there were some developers that were struggling with specifically with JSON. I think there was a bit of a struggle. It's a weak point in Go because of the static typing. So it's a trade-off that you pay. Working with JSON is not really fun, but it's safe. I'll give you that. So I think if I had to place a finger on a thing that was the hardest or the biggest surprise, where I heard most cries for give us Node.js back or JavaScript, we want JavaScript back, was working with JSON. We never switched to JSON v2 yet. I never got the chance to
I'm planning to do that next month once 1.26 is released.
So yeah, that's gotta be it.
And I do want to, it's fun to try and poke holes in success stories on the, so don't feel like we're attacking you, but it's just trying to understand how it really went down. The team at Venn, I assume, has some people that do backend, have some people that do front end. Did you have full stack developers as these sorts of developers, maybe more early on, that worked across the entire stack? Like you would give them a feature and they would implement both the front end and the back end?
So that might surprise you, but all of the developers at Venn are full stack developers. All of us, we do front end and back end. But personally, I think that no developer is really full stack developer. You do have a preferred side. It's like you're either left-handed or right-handed. You can't be both. Ambidextrous, just unicorns. It's not something that we really find. So we do have developers that became more back-end oriented. And I think that the switch to Go made it more obvious and more compelling for them to be more proficient on back-end development. Go is really, really suitable for back-end development. And I mean, the static typing, the no time, build time. I mean, you just press, everything's ready for you. The package system, the backwards compatibility promise, everything's just plays right to the hands of backend developers. And they still use JavaScript. We still use JavaScript for frontend. We do not share types. We can't share types anymore. And I think this is actually a good thing. This is not a bad thing. You should not share types between your frontend and backend. Eventually, what this will do, you will leak business logic to your front-end applications. And then when you find another front-end app that you need to create, you will find yourself re-implementing the same business logic that you already did in a different app. So when you have multiple frontends like we do, we have a front-end for an applicant, we have a front-end for the resident, we have front-end for the on-site team. We actually have a front-end which is not really a front-end because it's an LLM, but we treat it as a front-end. It's a new, and the technical landscape, LLMs became the new front-end. This is how you interact with backend systems today, like agents. So an agent is just another API, another front-end that uses the API. So we create an API that can serve all of them. We create backend for frontend, BFFs. And all of those BFFs, everything lives inside that modular monolith, which is very, very nice. So we converted all of those services into that monolith.
From an architectural perspective, I think the theme of 2025 and 2026 is definitely, simplify. I don't know what we all huffed in 2020 that we thought every single developer needs 15 Kubernetes clusters for their to-do app. But now it's like, you need one binary and it better be small.
Yes. And there's actually a great article by someone. I don't know if I won't find it, but there was an article that I read where the main quote was, "You're not Google. You're not Google. You're not Amazon. You don't have Google problems. You don't have Amazon problems. You do not need Kafka. You're not LinkedIn. You don't have those amounts of data to transfer. Just don't follow the trend and simplify." And this is exactly what we did. We removed the trends. We simplified. We actually no longer use orchestration. One of the most trendy patterns that we see around, or we saw, I don't know if that's still the case, is using choreography. It's where one service sends out an event to like a service bus, and there are a lot of other services that picks up that event and do their logic and send other event. There's Saga patterns and so on. Some use Kafka, some use SNS, or different service buses like RabbitMQ and so on. But that pattern is something that really shines when you have a big development team, very formal communication channels. And when you have a need to formalize the way that you communicate with another service, and you want to be as loosely coupled as possible from that service. But when you have a team of 8 developers or even 30 developers, everybody fits in the same room, you don't really need this. What you want is ease of maintenance, ease of debugging. So we switched to a pattern called choreography. You have a main, like a conductor, a main workflow that holds the logic of what needs to happen. And we use great infrastructure for that called Temporal to orchestrate all of our workflows. And it's actually written in Go. It started it was a project in Uber called Cadence.
As many of these software, pretty good, well-tasted software architect project. As Jonathan learned on one of the latest episodes where he had the guys talk about dependency injection and they changed his mind.
Oh, dependency is great. We actually use no dependency injection. I heard that episode and I was thrilled of hearing that I'm not crazy.
Yeah, I think that episode, whether you really like using dependency injection, whether you don't like using dependency injection, whether you like using a library, whether you don't like using a library, everybody came out of that interview pretty happy because their opinion was confirmed.
Hang on. Are you saying no dependency injection? Do you mean no dependency injection framework?
No framework. We do use dependency injection.
I would kill myself before I didn't use dependency injection.
What do you mean? Just initialize the database in every class that needs it.
Yes. Yes, please do.
New logger.
New logger. Or pass it in the context.
Yeah. Yeah, just put everything in context. That's why it's addictive any to any. If Rob didn't want us to use context, he shouldn't have created a library, you know?
Wait a minute. All right, Arthur. Well, it's been a lot of fun learning about Venn and hearing your success and all about rainbows and unicorns. Tell us how we can. Well, I was going to say how we can like follow Venn, although I suppose it doesn't matter to most of us unless we own an apartment complex. But what do you want to plug here? Well, let's just do it that way. I'll leave it open. Do you want to plug Venn? Do you want to plug a personal blog? Anything at all?
I want to say that Venn is really Venn just completed the round C funding tour, and we raised 52 million.
Okay,
congratulations!
Thank you. And we're growing. We're looking for developers that want to join our team and do great stuff here. We're touching everything from AI to data pipelining, API, front end. So if you really like touching everything and you like Go, just you can DM me. I'm at LinkedIn. I'm on Medium.
And links to your careers page, Venn.city, and your LinkedIn are in the show notes. So if you're listening to this and you're like, oh, how the hell do I spell Vaverko? Anyway, don't worry about it. The link is in the show notes.
In English, it's actually very simple, but try spelling it in Hebrew. You just get 4 different opinions. I mean, right. Thank you so much, guys, for having me. I love your work. Really do.
Thank you. And much. I think we're christening it's a new year, new us.
Yeah.
So if this is your first episode or you haven't followed, every year we did what we call a Sumper question, which is like the same question to all our interviewees that year. First year, it was what if you had to remove a feature from Go, what would you remove? And if you had to add a feature from another language, what would you steal from another language into Go? And we sort of ended up with all the features of all the languages on both lists. So it all canceled out at the end. Second year, what was it? I don't even remember.
What was the biggest surprise learning Go or something?
Yeah,
like
how long have you been doing Go and what was the biggest surprise or the most difficult thing? This year, I really like 2025, we had who was the person who influenced your Go journey the most. So it was very like personal and whatever. This year we're going back to a technical question, right?
Yeah, kind of.
Something that we can actually learn from. Jonathan, Arthur, please christen this new stumper question.
All right, Arthur. I hope you're ready. Drum roll, please. Arthur, what is your favorite Go library that's not in the standard library? And why?
Okay, so third party. I must say that GQL Gen gonna be the best one from 99 Design. This is a library writing GraphQL API with schema first approach. I mean, they have the entire ecosystem. They nailed it. They created a great developer experience where you can write your GraphQL schema. So you have an API schema where your front end and your back end share them, and the front can develop a client, a type safe client from that schema, and the back end using GQL Gen, you develop a type safe interface layer where you know exactly what you need to generate, and all the types are generated for you as well. So kudos to them. They're doing great work, and it's amazing. Easy choice.
Very cool.
Coverage 0. I'm opening the
oh my God.
gmail.com. This is what I'm seeing, but the Go report is A+. So I don't know, maybe they don't believe testing is cool. But I really like schema first approaches to development anyway. Like I'm the number one advocate of write your API contract first and then have something generate the rest. The more deterministic the generation, the better. Now you can honestly, if your API is really, really, really well documented and you have a DB, I feel like a lot of people are experimenting right now with writing the API in whatever, REST or GQL or protobuf or whatever, then using these exact type of generators to generate all the boilerplate, then using like Cloud Code or whatever to generate the implementation, just to have a really well documented schema first API. So I haven't used GraphQL for Go yet, but I can really understand why you're upvoting this specific one.
Yep.
Link in the show notes, of course.
Same. I haven't used GraphQL at that level, but I definitely appreciate API generators for gRPC, for OpenAPI, for whatever.
No, you really should try GraphQL. I mean, I was a REST advocate for a very long time. It's simple, it's nice. But the evolution of OpenAPI schema and the way that you need to be it's very verbose. It's very hard to read. And the schema has, I think it has, beside being a source of truth, it's like a documentation for the developer to know what's there and what's not. It's gotten really, really easy, hard and messy to work with OpenAPI and share models between. GraphQL is very, very simple. So I really encourage you to give it a try.
I could rant for hours about REST. I'm not sure that GraphQL is the right solution for many problems. I certainly see it's the right solution for some. But yeah, that would be a fun conversation for another day.
Yeah, now we also have to, when talking about all these things, we now unfortunately have to remember JSON RPC as well, because MCP is on JSON RPC. So for some reason that has resurfaced again. But generally, no matter, like, pick your poison, whatever language you choose to define your contract, having a good generator for that contract is always nice.
Absolutely.
Yeah. So shout out to GQL Gen, link in the show notes as well. Arthur, thanks so much for coming on our show.
Thanks for having me.
It's been a blast.
I love your work. Right. Thank you.
Thank you. Until next time.
Okay.
Program exited.
Program exited. Goodbye.